And away we go. Hey, welcome to the second video for Trig Pre-Calc. Here's the do now again, warming you up. Pause the video, do it. I would recommend just using the formula that I just made the video for. Answers. 4 is singular. You can see no inverse exists. Again, anytime I flash anything up on the screen, pause it so that you can look at it. Assignment from last time, yeah. Oh, that has been posted to my website for you to look at on, yeah, it's in a PDF. Alright, cool. So, sections 7.7 to 7.8, the determinant and Cramer's rule. 7.7 is the determinant. 7.8 actually has a couple of applications of determinants. We're just doing Cramer's rule. So something you have to know is every square matrix has a number associated with it. This number is called the determinant of the matrix. It is just a number that describes something about the matrix. We can actually do a whole bunch of stuff with it. You can see right here, solving a system of equations. We can get these solutions right here. Really, that's not the important part. The important part here is determinant. Determinant. You can write it as det of A. You can use the absolute value brackets of A. But what it gets down to is it is A1 times B2 minus A2 times B1 if you're doing a 2 by 2 matrix. So there it is right there. That's what you need to know. Determinant of A is equal to, you can write it as the absolute value bars. They don't mean the same thing, but yeah, it looks the same. You can also just put the magnitude bars around the matrix instead of having those square brackets. Just put straight bars there. But what it comes down to is A1 times B2 minus A2 times B1. It's the product along the main diagonal minus the product on the secondary diagonal. It's actually the denominator of the formula from the inverse matrices. So it's an actual important thing. Yeah, pause if you need to get the formula down still. Here are 6 matrices to find the determinant for. Finding the determinant should not be hard. All you have to do, the determinant of matrix A, multiply along the main diagonal, 2 times 2, well, let's just write it out so that we can actually get the work, minus product along the secondary diagonal, negative 3 times 1. 4 minus negative 3 gives me 7. Done. Please do not make this any more complicated than it needs to be. I'll pause the video if you want to do the remainder of these 6. And I'm picking up again, just looking at this one. If I wanted to find the determinant of B, really what I would write down, 4 minus 4, 0. Maybe not even write that much down. Over here on number 3, if I wanted to find the determinant of 0, 3 halves, 2, 4, just giving you different ways to write it there. 0 minus 3, negative 3. I'm alright with you just putting the number down. That's fine. Yeah. Det of D, 12 minus 12, 0. Determinant of E, 14 minus 12, 2. Determinant of F, 8 minus 9, negative 1. Answers just to make sure that I did it right. Again, don't overcomplicate it. Which, speaking of overcomplicating stuff, finding the determinant of a 3 by 3 matrix, if you really want to see how to do it by hand, you can look in your calculator, or look in your textbook. Your calculator doesn't actually have that kind of information in it. But your calculator can actually find the determinant of a square matrix. So, steps right down here. I'm just going to run through it with you. If I want to find the determinant of this matrix, go into your matrix menu. In your matrix menu, just store that matrix right there. So 3 by 3 matrix, 0, 2, 1, 3, negative 1, 2, 4, 0, 1. Boom, got that. Go to your home screen, go back into the matrix menu, go over to math. First option is DET, matrix A. Determinant of A is 14. If you have to find a determinant for anything higher than a 2 by 2 matrix, that's how you want to do it. Now, on to Cramer's Rule. Cramer's Rule, you have to be able to find the determinant of each matrix. So you can look here, pause it if you want to see it, or if you want to copy it down, you can see we actually have the system A1x plus B1y equals C1, A2x plus B2y equals C2, x is going to be equal to C1b2 minus C2b1 over A1b2 minus A2b1, but really looking at that, that's just the determinant of this matrix called D sub x. This is the determinant of this matrix called just D. Down here, y is going to be equal to A1c2 minus A2c1 over A1b2 minus A2b1, which this right here is just the determinant of this matrix in the top there. We call that D sub y. This, identical to the denominator from x, it is the determinant of the same matrix. Again, still called D. Cool. Now all we have to do is set up D, dx, and dy. I'm going to point out the matrix to determine D, A1, A2, B1, B2, is just the coefficient matrix. So right here, to determine D, you can see I actually have a system right here. Maybe write that down. D is going to be the determinant of the coefficient matrix. So 1, negative 4, negative 5, negative 2. To get that determinant, do what we just learned here. Negative 2 minus 20 gives me negative 22. D sub x, looking at D sub x, notice how the second column is exactly the same as the D matrix. The only thing that changes is the first column, and those numbers come from the solution, the solution to the system. So to find D sub x, what you do is you delete the first column and replace it with the solutions. So D sub x, let's see, take away 1 and negative 4, make it into negative 5 and 20. Second column stays the same. So now what I have here is dx is going to be equal to negative 5 times negative 2, 10, minus negative 5 times 20 gives me 100. 10 minus negative 100 gives me 110. D sub y, if I look at dy, matrix is the same as D. The only thing that has changed here is the y coefficients have been deleted and replaced with the solution. So looking over here for dy, again, I take D, keep the first column the same, the x coefficients the same, replace the y coefficients with the solutions. So dy is going to be 20 minus 20, 0. Boom. There we go. And again, just to show that I have those right. Now for what Cramer's rule actually is. Cramer's rule, if a system of n linear equations in n variables has a coefficient matrix A with non-zero determinant of A, the solution of the system is x1 is a1 over a, determinant of a1 over a, determinant of a. x2 is determinant of a2 over determinant of a, blah, 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 where the ith column of A sub I is the column of constants in the system of equations. If the determinant of a coefficient matrix is 0, the system has either no solution or infinitely many solutions. Again, pause if you want to come back to that one. The back of this page just has us revisit the exact same system from a few slides ago, so I'm just going to put that back up here. Again, we found d, dx, and dy. The only thing left for us to do is determine what x is and what y is. What Cramer's rule just told us to do is for x, you take d sub x and divide by d. That's just 110 divided by negative 22. Oh man, I'm gonna cheap out on this one. 110 divided by 22, 5. This would be negative 5. Y is going to be dy over d. 0 over negative 22. Beep, bop, boop, boop, boop. 0. So the solution to my system, xy, is going to be equal to negative 5, comma 0. And that's it. I mean, you can check your you can check that system to see if it actually you can check that solution to see if it's correct. I mean, negative 5 minus 5 times 0 gives me negative 5. Negative 5 times negative 4 gives me 20. Minus 0 gives me 20. Hey, cool. It actually checks out. So there is Cramer's rule. Again, there you go. Now here's 3 systems to solve using Cramer's rule. Pause the video to practice it. And now you can unpause just to show you how I would do this. D is going to be equal to the determinant of negative 1, 5, 1, negative 2. D is just the coefficient matrix. Coefficient matrix. Negative 1 times, so 2 minus 5 gives me negative 3. Dx, delete x, and replace it with the solutions. So 2, negative 2, 5, negative 2. Negative 4 minus negative 10 gives me 6. Dy, delete the y column. Negative 1, 1. 2, negative 2. Negative 2, 2 minus 2 gives me 0. X now is going to be equal to dx divided by d. 6 divided by negative 3, negative 2. Y, 0 divided by negative 3 equals 0. X comma y equals negative 2, 0. I'm going to skip the middle one. I'll put the solutions up here in just a second so you can see them. But what I really want to focus on is this one. Over here, when I do my determinant D, I've got the determinant of negative 1, 3, 3, which would be negative 3 minus negative 3 equals 0. Alright? Now, Cramer's rule says D cannot equal 0. If D equals 0, you have either infinite solutions or no solutions. In order to find out which one it is, I just find one number that works here. So 0, negative 1 is going to work. Just trial and error, I get that one. 0, 1 is going to work in that first equation. If that solution works in the second equation, infinite solutions. If it doesn't work in the second equation, no solutions. So looking here, I've got 3 times 0 plus 3 times 1. Does that equal 3? Yes. Infinite solutions. Boom. Cramer's rule. Rule. There's the work for the second one. There we go. Cool. 3 variables is extremely similar, but you have to use a calculator for it. So, let's see. D. D is still the coefficient matrix. My phone keeps falling over, in case you guys are wondering what that sound is. I use it to see what you guys are seeing on the on the video. 5, 1, negative 4. No x, so 0, negative 3, negative 6. Negative 1, negative 1, negative 1. Find this determinant. If only somebody had told you how to find the determinant. Matrix, edit, 5, 1, negative 4, 0, negative 3. Whoopsies. Negative 3, negative 6, negative 1, oops, negative 1, negative 1, and determinant of matrix A is 3. dx. We find the same way that we found dx in that first, in that other example. dx, delete the x column. Replace it with the solutions, negative 4, negative 21, negative 6. Second and third column stays the same. Punch that in, find your determinant. 15. Again, I'm just using my calculator right over here for that. dy, found the exact same way as in the last example. Delete your y column, replace it with solutions. So 5, 0, negative 1, kept the same as d. Solutions being negative 4, 20, negative 21, negative 6. Third column, exactly the same. Punch that into your calculator. You should get negative 15. And now, last but not least, the new part, dz, is done the exact same way as dx and dy, but big surprise, you're going to delete the z column and replace it with the solutions. So 5, 0, negative 1, 1, negative 3, negative 1, negative 4, negative 21, negative 6. Punch that into your calculator. You get 18. Now for the really difficult math here. To find x, you do dx divided by d, which would be 15 divided by 3. Last time I checked, that's 5. Y is going to be dy over d, which will be negative 15 over 3, which gives you negative 5. And last but not least, z is going to be dz divided by d, which is going to be equal to 18 divided by 3, which gives you 6. You really want to check this so that you didn't make any dumb mistakes like typing stuff into your calculator wrong. But we've got 5, negative 5, and 6. Work. Some practice problems for you guys. Pause it so you can practice it. And the solutions. And your assignment. Done.